Okay, let me now define pattern matching for this maybe. Pattern matching for hierarchies is the equivalent, this is the functional equivalent to polymorphism. So I will go here and I will write a new method that I will call match with. And this will again take something that I will call a pattern, and this, let's say that this is abstract again, so I will throw an exception here just in case. And now what we are going to do is I will implement, let me display how I'm going to use that to be more easy to understand. So inside the match with, what I want to pass is an object, literal, that has two parts. Has something that's called a sum, and here we do something with that. Takes a value and we do something with that. And also we have this thing here that it's for the none case. So we want to be able to write something like that. You see, in the case of the sum, I assume the pattern that has this form. So I want to access this and pass inside a value. So I will do this. And here pass inside the value. And in the case of none, just do this none, and does nothing. So in this way we can separate the two situations in a single statement. Basically it's like writing a case statement, but it's reversed. So that's how we usually write, and if we try to run that, we will see that, let me put a breakpoint here to see that we are actually going to reach this where the v is 4 as expected. If we change that to none, we expect to reach this case. We match this case here, but we don't have a v, so we'll just throw to go here correctly. And so that allows us to separate. Because I put here a return, this means that we can just do things with the value and return something specific. So for example, we could do that, right? In case of none, return 0. We'll see specifically how we use that, but pattern matching is an awesome functional way to separate cases in hierarchies. So if I add here this, we will see that t is actually, t should be 0, and if I have a sum, obviously you expect to see the square. So pattern matching is a way to extract the value out of the functor in an elegant way, and it's consistent throughout. So you'll see that we will apply pattern matching to all our favorite monads and factors. So that's for pattern matching with the maybe functor, and now we'll turn maybe into a monad by adding a bind method.